Hello my dear friends, I'm Dr. Vaishali Bharambe, Professor Anatomy. We just finished fertilization. The question is, how does that microscopic embryo travel from that spot to the uterus, implants itself perfectly? How does that happen? This is the journey you are asking an embryo to take when the embryo is barely a couple of cells old. Okay, it is a journey, isn't it? See how it's traveling. Finally implanting. So how and why does this happen? Today is about this, the journey of the zygote from the point where it was formed in the ampulla of fallopian tube to the point where it got implanted into the uterus. The first week of our little zygote's life. Come, let's travel the journey with the zygote. We don't know whether it's a girl or a boy. Okay, come. So the zygote is formed when a sperm and an egg combine into a single cell. You know that, I know that. We don't even call it the egg. You know we call it the secondary oocyte, right? But finally when they combine and they form a single cell, you call it a zygote, right? Okay. So in the first week of intrauterine life, we are going to understand the development of this zygote. For that, we need to understand what is a zygote. Why am I calling it a zygote? Why not call it an embryo? So let's define some terms. Embryology requires us to sometimes define. So zygote is when there is fertilization and there is multiplication of cells. Till a few, individual cells cannot be identified. It's just a cluster. Then comes the embryo. From here till the end of 8 weeks. From the time when there is a central group of cells and an outer group of cells, the central group of cells will multiply till they begin to just produce something that resembles an organ. Okay? So till that time is the embryo. And then from that point where there is tentative formation of organ to actual formation of the baby itself, it's a fetus till the day it is born. Now what happens? At birth, you're going to call it a neonate. From birth to 28 days of life, the baby is a neonate. It's not a zygote, it's not an embryo, it's not a fetus. It's a neonate. And from that point till 1 year, it's an infant. See, in a conversation, we've traveled from being a zygote to an infant. Yes? So let's enjoy this sweet little journey of the zygote. First week of fertilization. The events that occur in this time, in the first week, are cleavage division, formation of morula, formation of a blastocyst, and finally implantation into the endometrium of uterus. Please close your eyes and think. What am I saying? Cleavage, morula, blastocyst, implantation. Just 4 steps to be done. Let's begin with the conceptual understanding that what are we beginning? We are beginning with this single cell zygote. We are going to produce this little baby. Please note that the zygote is surrounded by zona pellucida. That is something very important and you must remember it. And please never forget that that's the little baby we want to finally create. Come. So, cleavage division. What is this? Actually, it's just a division of cells from 1 cell to 2 cell, to 3 cell, to 4 cell. These cells are called blastomeres. They're called blastomeres. It's just cells multiplying. But there's something very peculiar going on. Come take a look. As the cell divides, it goes on becoming smaller in size. Why is that? How will the baby ever grow up if we're going to keep on making the cell grow smaller and smaller? The cell is not increasing in size because it is still enclosed in zona pellucida, which is not an elastic structure. It's a proper cover. So if the number of cells is multiplying, fine. But the cytoplasm is not going to increase. Just the number of cells is increasing. Okay, so that's something you need to note. Please never forget that there is zona pellucida here today. Right. So from this time we go on to the next layer, next step, which is formation of morula. Okay. So what is morula? Cells multiply and they form a 16 cell cluster. Okay, and it looks like a mulberry. I hope you've had the pleasure of eating a mulberry. Okay, so it looks like a mulberry and therefore it's called as a morula. Okay, then while these divisions are taking place, where is the zygote? Okay, what is happening in the travel of the zygote? So location of the zygote. While these divisions are taking place, the zygote is traveling along the fallopian tube towards the uterus. Who is helping it in its travel? The beating of the cilia of the fallopian tube. They're just pushing the zygote along. Come on, a little further. Come on, a little further. Trying to push it towards the uterus. Okay? And by the end of 4 days, it would have almost reached the uterus. It has traversed the fallopian tube. Who has helped it? The fallopian tube itself. Okay. So, take a look. Here's the zygote, 2 cell, 1.5 day. Morula, day 3. Okay. So, now you will see that the cells of the morula are dividing themselves into 2 groups. An inner cell mass and an outer cell mass. What is this? Come, let's understand. Cells get a little packed together and by nature they get divided. The inner cell mass, can you see the light pink cells? These are going to actually develop into the embryo. Okay, and they're therefore called as an embryoblast. And you can see, yeah, that's it. And then here you're seeing the outer greenish colored cells. Of course, they're not of this color, but it's just for you to understand. So outer cell mass, these cells are going to produce the placenta and they are therefore called as trophoblast. Okay, you should by now be able to visualize a ball of cells, inner core, inner cell mass, outer cells, outer cell mass. Okay, I hope you're enjoying this because I'm loving it. And if you're liking this, please like, share and subscribe to my channel and hit that bell icon. Okay, students, I have a beautiful website on which all these lectures, surgical anatomy videos and a lot of MCQs, downloadable notes are all available. So please visit my website vbanatomy.com. Link is in the description section. Right, so where is the morula? What is happening in the uterus? The morula has just entered the uterine cavity. The uterus is under the influence of hormones and is in secretory phase. What is that? It's secreting a fluid which is called as uterine milk, which is highly nutritious. Okay, so what happens? We go to the next stage related to the uterine milk, formation of blastocyst. So what happens is this uterine milk that has been secreted by the uterus slowly begins to make its way through the zona pellucida into the group of blastomeres, creating a cavity in the center which is called as the blastocele. It's a fluid-filled cavity. Okay, so and this structure is now called as a blastocyst. Blastocele, fluid-filled cavity. The structure is called as a blastocyst. Of course, there is an inner cell mass is pushed to one side and the outer cell mass is surrounding the cavity. Right, as shown in the image. Okay, now what happens? The point where the inner cell mass is attached is called as an embryonic pole of blastocyst. Please note that. The point where the inner cell mass is attached is called as the embryonic pole of blastocyst. The other end is called as the abembryonic pole of blastocyst. The trophoblastic cells themselves get divided into 2. The polar trophoblast where the inner cell mass is attached and the mural trophoblast is the rest of the trophoblastic cells. Students, at this point you should be relaxing and trying to quickly revise what we have done. Okay, maybe have some coffee like me. It's very important that you learn to relax in your study time as well. You must be thinking, what is madam saying? It's really important. If you don't spend time on relaxing yourself, revising what you've done at short periods of time, there's no point in the study because you're not going to remember. Okay, so I hope you've taken that time out and let's continue. Here is the mural trophoblast. So 2 types of trophoblast, polar trophoblast, mural trophoblast. Two poles, embryonic pole, abembryonic pole. Right. So let's ask ourselves some questions. Okay. Two cell masses. Yes. Inner cell mass, outer cell mass. Two poles, embryonic, abembryonic. Cavity of blastocyst, blastocele. Inner cell mass forms. What does it form? Yes, it forms the embryo. Outer cell mass forms the placenta or the trophoblastic cells. Two types of trophoblastic cells. Yes, polar trophoblast and mural trophoblast. Okay, these are basics, foundation blocks of what we're going to do later. So you have to know this. Right. One quick revision, asking questions now. Come on, start answering. What is this? Inner cell mass. This, outer cell mass. This pole, embryonic pole. This pole, abembryonic pole. These group of cells, polar trophoblast. These group of cells, mural trophoblast. Fun day clear? Come on. So, where is the blastocyst? We keep asking ourselves this question because blastocyst is traveling, no? So, we have to know where it is. So, now take a look. This is your blastocyst on day 4. And it is now going in for the final attachment, implantation into the endometrium of uterus. Come. So, question is, implantation begins on the 6th day. Where to implant? There's quite a big uterus there. Where do you want it to implant? The best point for implantation is fundus of uterus along the posterior wall. Anything in the upper half is good, lower half not so. Okay, so somewhere here should be the site of implantation. Timing is around 6th day and implantation consists of following events. A lot of things happen. It's quite an event in the life of the little zygote as well as the mother, of course. So, zona pellucida has been quietly holding the cells, preventing implantation. So, that has to go. Then, blastocyst has to finally stick to the endometrium and migrate into the endometrium, right? And then trophoblast has to spread. So let's begin to do this step by step. Loss of zona pellucida. So this comes as a short note very often, so please prepare it well. Zona pellucida begins to disappear. For that you have to know what function was it performing till now? Why did it persist? So remember, zona pellucida and its journey started long time ago, even before the fertilization, isn't it? So what it was doing was, it was allowing only species-specific sperm to fertilize the oocyte. Okay? So think about it. Then it was preventing multiple sperms from fertilizing the oocyte. Polyspermy was prevented. Then it was inducing acrosome reaction, allowing that one sperm to penetrate inside. Okay? Then it was acting as a barrier, preventing early implantation. Just imagine if that embryo decided to implant inside the fallopian tube, what would happen? Okay, do you think your fallopian tube is really capable of bearing an embryo, allowing it to grow to full term? No, fallopian tube is going to tear. So you don't want that. That is prevented by ZP or zona pellucida. It is holding the blastomeres together and preventing early implantation of the blastocyst at any abnormal site. Right. So then why does it disappear if it's such a great thing? Why do you want it to go? You want it to go because the embryo is hungry. Embryo is growing. It's needing a lot of nourishment. With the barrier of zona pellucida, not enough nourishment is coming in for the speed at which the zygote is wanting to grow. Right? So what happens? The blastocyst wants direct nourishment from the mother's uterus. So zona pellucida has to go, and it goes. Zona pellucida is now disappeared. So take a look. That's the blastocyst. That's the ZP slowly disappearing. The cells are multiplying and aligning to finally create something that looks like this. Okay, inner cell mass has increased. Trophoblastic cells have flattened out and have now nicely they are supporting the cavity of blastocyst. So, what is the uterus like today? Uterus is so full of secretions and glycogen and lipids, and it's just there to encourage the a zygote to implant. Okay. What is the state of embryo? Embryo is not covered by zona pellucida, therefore ready to implant. Isn't it lovely? Okay. Yeah, the uterus, every menstrual cycle, the uterus hopes for a fertilization, hopes for an implantation, and therefore it goes through the cycle of creating the scenario which is perfect for implantation. Okay. Remember, the main aim of nature is to maintain the species. Okay. Procreation is the most important activity that happens in nature, and that's why the whole biology is aimed at supporting that procreation. Right. So now what the embryo does is, or the blastocyst does it rotates so that the embryonic pole, where the inner cell mass is, comes in contact with the uterine epithelium. See? Okay, so it is reorienting itself, right? Now, the trophoblast is very sticky by nature, so it sticks to the uterine epithelium. But is the uterine epithelium saying no to this? No, it is also encouraging the sticking. Okay, they have receptors which bind to each other, causing the blastocyst to stick there. In the next step, it begins to multiply and enter into the endometrium in the form of proteolytic action. So it's causing proteolysis. Uterus is encouraging the proteolysis. Okay, and that's how the blastocyst begins to enter inside. Okay, and you can see that the trophoblastic cells are now dividing into two types: Syncytiotrophoblast and Cytotrophoblast. This is a major event. I hope you're noting this. This is the Syncytiotrophoblast, and this single group of cells is a Cytotrophoblast. See how Syncytiotrophoblast is multinucleated, but you can't really tell the cell walls. Come, let's compare these two parts of trophoblast: Syncytiotrophoblast, Cytotrophoblast. Syncytio is the outer layer, cyto is the inner layer. Syncytio is multinucleated versus mononucleated Cytotrophoblast. It has no cell wall. This has clearly seen cell walls. Stains very deeply. This one stains quite lightly. Syncytiotrophoblast gives rise to finger-like projections into the uterine epithelium, into the endometrium, okay, that help to erode the maternal tissue, allowing the blastocyst to enter deeper and deeper. Cytotrophoblast actually provides the cells for Syncytiotrophoblast. So where is the blastocyst now? We come back to our favorite question. So this is where the blastocyst is. See how it's slowly getting implanted into the endometrium. It is day 6. Right. So implantation consisted of all these steps and formation of Syncytio and Cytotrophoblast. Are we ending the game today? No, we still have one day to go, the day 7. What's happening here? The inner cell mass has decided to further classify itself. See, this was the cluster of cells. This gets divided into two cells, two groups of cells. Epiblast, which is a group of columnar cells, and a hypoblast, which is a group of latent cells, which are adjacent to the blastocele cavity. This is a big event because now epiblast and hypoblast will take on the development of the embryo. So students, I loved taking this session with you. I'm just excited to see how the embryo is going to develop now. I hope you're excited too. I love embryology and I'm going to try my best to make sure you love it too. Okay, so right, I hope you like this lecture. Please like, share and subscribe to my channel and hit that bell icon. Please visit my website vbanatomy.com. There are lectures, there are surgical anatomy lectures, downloadable notes, MCQs and much more. Link is in the description section. Students, I have a request for you. Can you please comment for this lecture? Because unless I get a feedback from you, I don't know whether I'm really making a difference. And I'm out here to make sure that every anatomy student receives optimum anatomy education. Not less, not more, but optimum. Okay, so if you give me a feedback, I can give you further details. I'll be most happy to. or you want it only till here. In either case, I'll see you in the next lecture. What did we cover today? We covered cleavage division, blastocyst formation, loss of zona pellucida, sticking of trophoblast, implantation with syncytiotrophoblast formation, finally epiblast and hypoblast. Next time we will be starting from here. That will be the second week. Remember that there is something very fantastic happening in embryo at this stage. Think about it. The cells that are there today are embryonic stem cells. These are cells that can produce anything, and these are the stem cells that can be harvested to produce spinal cord, to treat diabetes and so on. Adult stem cells are not that effective. Okay? Remember that this zygote got implanted, but if it was abnormal, many a times it gets aborted. Almost half the zygotes that are formed are aborted, and the mother doesn't even know it. Okay? Sometimes during cell division, okay, one of the cells goes into an abnormal cell division, and then each of these cells goes on multiplying. An embryo is formed with two types of different cellular contents. Such a person is called as a mosaic, and this is called mosaicism. I've talked about it in some of my other videos. I'll put the link in the description section. If you want to know more about it, do please watch that video. Finally, remember that there are a lot of inherited disorders. Sometimes a cell from here can be taken out and studied for presence of that disorder. And if that baby has that disorder, maybe something can be done about it, or of course, aborted. Okay? So, next lecture will be second week of intrauterine life of embryo. I've already shared videos with you on spermatogenesis, structure of a sperm, oogenesis 1, oogenesis 2, fertilization and applied aspects of fertilization, including artificial reproductive therapy. Link is in the description section. Thank you. I enjoyed myself. I hope you did too. Bye.